Install the Tahoe Overlanding sleeve kit for the Dodge axles. We're going to install the Tahoe Overlanding Dodge disconnect axle sleeve kit that vastly strengthens not only the differential axle housing by completely sleeving and bypassing the CAD housing, while also giving you stronger axle shafts because it uses a chromoly axle shaft. We'll be installing the Welding axle sleeve. We'll be installing the seal relocation kit and the one-piece axle shaft. Stay tuned. This is the axle that we use for the Tahoe Overlanding solid axle conversion on full-size Chevys, but it also works on Dodge trucks because it's just a Dodge axle. So this is for everybody. Here's what you're going to need. You're going to need a power drill. You're going to need a 2 1/4 inch hole saw, preferably one with some carbide teeth, a good metal hole saw, then a 1 5/8 hole saw of the same brand. You're going to need a 1/2 inch drill bit that's going to be good for drilling your axle tube. You're going to need a long 3/8 drive ratchet extension. You're also going to need a 3/8 drive adapter for your drill. This kit from Harbor Freight works pretty good and it's pretty cheap. You're going to need a welder. You're going to need a tube of RTV silicone. You're going to need a 1/4 inch drill bit. You're going to need a 5/16 by 18 thread tap. And you're also going to need an 1/8 inch NPT thread tap and drill bit. And you don't need this next part, but it sure makes it a lot easier. If you have a differential seal driver, you can get one on Amazon for like 25 bucks. It makes it a lot easier. We've got the brake rotors and calipers off. We've got the unit bearings off. We've got the outer axle shafts off. But there's still an axle shaft in here. This center axle shaft needs to come out before we can get the gears out. Take this off so we can get the next shaft out. See how it's kind of shifted down? Can't really get that shaft out without pulling this shift collar. So there is a seal down in there, right there, see it? We're gonna knock that seal out. We're not gonna use that seal anymore. So you have to pull the ring gear out because we're going to add a seal down inside there. And we actually are going to reach in with the welder and weld the inside of that sleeve to the axle tube as well. Now that all the axle shafts are out, we'll get the gears out. Whoops. So we installed this sleeve kit. We're going to reach in and weld the end of the sleeve to the inside of the axle tube with the welder in here. And we're going to install a seal relocation kit right here. So the seal will get moved from right here to in here. And then it will be the exact same seal that's used on this driver's side on this side. Okay, so the sleeve kit is going to weld in on this axle tube. So what we're going to do is we're going to drill some holes in the axle tube and do some plug welds to attach the sleeve to the axle tube. We're also going to weld it down around the inside the differential housing. We'll reach in with the welder and weld it in here. And out here at this end, we'll do the exact same thing at the opening of the axle. We also have these gussets that are going to actually weld in, attach to the sleeve, and attach the sleeve to this outer CAD housing. There's a bearing right there, and some axles have a bushing. Either way, you've got to knock that out, and we're going to actually cut that out using a hole saw. I'm just going to knock that bearing inward, and since we've got the gears pulled, we can actually just push it through and retrieve it right there. That's the easiest way to do it. So this is the needle bearing. See it in there? So Dodge updated it to a bushing, and either way, you extract the bushing or the bearing. This one looks like it had a bearing still in it. It's like a plastic bushing down in there. Either way, you've got to take it out. I'm going to remove the pilot bit, install the 2 1/4 hole saw in it, and then see how there's still some threads exposed? You're going to install the 1 5/8 hole saw. And that's going to be what actually pilots you through the holes you're cutting. But you're going to have to do this down inside the actual CAD housing. That's why we're taking the pilot bit out too. So we're going to take this back apart. You just want to make sure that it all works. You're then going to use the right size socket to go on here. A socket extension, and an adapter for your drill. So then you can reach through with your drill and actually spin the hole saw, because you can't push the hole saw all the way through. See how that doesn't work? You really have to unthread this. Put that down inside there. See, look. You see how it just fits down in there? So with your extension, you're going to reach through from the outside and get those started. Okay, so you got the one started. Now we just got to get the other one. You kind of got to use your fingers. It's kind of a pain, I know, sorry. You'll see the hole saw changed colors. I had to go get a sharper hole saw. The one I was using was pretty old and worn out. I've been using this for a while, so I went and got a sharper hole saw. So the piece that we're cutting is about a 1/2 inch thick. So we've got to keep going, and once it goes through, it's gonna, the end of the axle tube is right there, so it's just gonna fall out. Okay, so it looks like, yep, we got it out. Here's what we hole sawed out of there. Look at that. That's what we used the hole saw to cut out. You can see it's about that thick, not even a 1/2 inch thick. And it's just a piece of casting of the CAD housing. So the axle tube ends, and it's pressed in to these plug welds. And this is just a piece of casting right here that we're just cutting out so we can have a tube push all the way through. For getting gear oil off of stuff and cleaning out differentials, I actually prefer starting fluid. I think it's the best. So I like to use starting fluid to get most of the stuff off, and then something like brake cleaner with no residue to come back after if we're going to be doing some like welding. It breaks up that stuff a lot. Clean this out, but you're also going to have to clean out the tube. This is going to be full of grit and dirt and 20 years worth of garbage that's going to get pushed into right here. So clean it, but you're going to do a final clean after you've cleaned this axle tube out too. Okay, so now we got to start drilling holes through the axle tube. We are going to weld. We're going to reach in, and we're going to weld in here. We're going to weld at the other end. We're going to drill some holes, do some plug welds. You don't need to do a whole ton of plug welds, but you need to do a few. So drill a few plug welds, and that's going to be what ties the axle tubes to the center sleeve. And then the two ends are going to give you some real good support, and then we'll have a gusset in the middle that ties into the CAD housing and ties it that way. So welding cast doesn't really work well, but I want to drill some holes through the cast into the axle tube that's behind the cast to actually tap that axle tube into the, into the sleeve. So I'm going to use one of these. This is from Harbor Freight. It's like 20 bucks. It's a kind of an annular cutter, better than a hole saw. You could probably use a hole saw too, but this was like 20 bucks. It's like 7/8. It's the perfect size. So I've already drilled a 1/4 inch pilot hole, and all I'm going to do is drill part of the way through, just through the casting, just to get the casting out of the way so that I can drill a smaller hole and plug weld that. So you can see that plug is removed, and that's just the axle tube under there. So now I'm going to drill that out to 1/2 inch and then weld that. See, so that's down in there, where I can get the welder down there, and this is actually the casting that's been kind of cleared away. Okay, next up, we got to figure out how deep to weld the axle sleeve in. Later on, we're going to install this seal. Now this seal is going to go right there. You need to have enough room for that ramp of this seal to clear the actual axle sleeve plus your weld, because you're going to reach down in there and weld right here. And this seal is about 7/8 of an inch thick. So I like to give it, an inch, 1.25 in from this outer edge where the carrier bearing rests, just to give it enough room. So I just take the tape measure and just push on the shaft to right there. See the shaft down in there? And we're going to go in and we're going to weld in there. And you see on this side too. Clean it out with some brake cleaner, some gunk, just some contaminants. Okay, here's where the 1/4 inch drill bit comes in. After this has been welded in place, these 2 holes right here are just blind 1/4 inch holes. Don't go in very far. You're going to extend them all the way through the axle sleeve that's been welded in. All right, this is where your 5/16 18 tap comes in, and a little bit of oil. It's always good to tap with oil. And we are going to just tap this hole to 5/16 18. And the reason why we tap this is that just bolting the plate to right here only really strengthens right here. These outer holes are going to keep any kind of strength at this outer edge too. What I'm doing here is fitting in the gusset that goes into the inner sleeve and welds to it with the jig that you can see on the left side. That jig centers inside the rectangle shape of the CAD housing and holds that piece in place so that you can tack weld it and then remove that jig and full weld it and have it lined up right where it needs to. And before you full weld, double check that this lines up with all the bolt holes in the right place. Some slight adjustment before you full weld might be necessary. Now everything's lined up, it's time to full weld that gusset. There you go. Everything's still lined up. Now what comes in the sleeve kit, I'm not going to use. It's totally unnecessary, but I provide it for those who really want it. Is this piece goes down in here and then you can weld it to this cast housing. But only use this if you have the ability and the time to actually properly weld mild steel to cast. And that's preheating, it's using the right filler metal, that's post heating, that's keeping it cooling down at an even rate. So if you're not going to do that, don't use this. It's totally unnecessary anyway, but I do provide it. Okay, now it's time to bolt this on. Using the bolts we provide in the kit. Since these holes are so precisely spaced, put in the bolts loosely first. So these 2 bolts on the outside are going to help with any kind of spreading or deflecting of the whole CAD housing. And you're just welding that inner gusset to this plate here. And there it's now all just joints. These 4 bolts are holding the plate to the center section of the CAD. These 2 bolts are keeping everything this way. So if there is any weakness introduced by this opening in the CAD, we've kind of canceled it out with this. Okay, so now see this silicone glob? That's from the manufacturing of the axle. We got to get this out of here. Comes out pretty easy. Okay, so now it's time for the seal carrier. Get in here, we're going to clean up the end of the axle tube and this lip with brake cleaner. We've already kind of cleared the silicone off. It comes right off. This is the silicone from manufacturing the axle. Just pull that out and then clean this with brake cleaner. The easiest way to do this next part is to use like a seal driver. You can get something like this off Amazon for like 25 bucks. I recommend you get one just to have, because this is how you'll change out the seals for both sides anyway, so they're just good to have. So now we're going to install the seal carrier, which is this thing right here, and it's going to press into this machine surface right there. And then it's going to hold a standard Dana 44 style seal. That's the same kind of seal that's actually on this side, so now you'll have the same seal on both sides like a regular Dana 44. Now your RTD silicone usually comes with one of these nozzles. I like it. We're going to put silicone down in that groove where the original silicone actually was. The reason we put that silicone down in there is just in case this machine surface doesn't seal really great on this seal, because this machine surface can vary just a little bit. So a little bit of silicone will go a long way. This has two sides. This is the side you normally drive seals with, but this bigger side is for different axles, but we're going to use the bigger side to drive this. And this is a tight fit, and we want it to be. And we're going to go until that seal carrier bottoms out. You need to just wipe with a clean rag the excess silicone from down in there. You don't want that. See, there's a lot of excess silicone. Next up, it's time to do the seal installation. And this is just a standard Dana 44 seal used on Dana 44s for like the last half century. Easy to find. As I mentioned before, it's the same seal that this differential already came with from the factory anyway, so now you have two of the same seal, which is better than having two different seals. As I mentioned, this now gets flipped around, so it fits that seal perfectly. And you want to make sure that your seal carrier is just past. You can hook a fingernail on this machine's surface. That's how you know it's at the right point. So you hear that? I can hook my fingernail so the seal carrier is just past that point. That is how we convert these CAD axles to have a standard seal when we delete the CAD. Instead of these weird, expensive, and ineffective tube seals. There you go. Deleted the Dodge CAD and converted it to a standard style seal at the same time. Now be sure to put some clean grease down in there on the lip of the seal before you install the axle shaft. Right here, put some clean grease right there where the axle's gonna ride. I totally forgot to record it before putting the gears and locker back in, and I don't wanna take the wiring back out for the e-locker and re-silicone the grommet and everything. So I'll just show you. So you need to drill a vent tube because originally the vent tube was in the CAD housing, but now we've moved the seal to here. You need the vent tube to be where the actual gear set is. So this one already had an e-locker already drilled right here, but this is actually a really good spot to drill it. But since that was there, I actually put it here, and I've checked to make sure that it'll clear and not hit anything as the suspension goes up. But right here's a really good spot. And you just need an 1/8 inch pipe thread tap, drill a hole, put your vent fitting from your CAD housing right there, and you're good. Avoid putting it anywhere in this plane because there's some pretty good flinging of oil that happens as this is spinning, and then it can force oil up the tube. So you want to set it away from in line with the gear.